Welcome back, everyone. We're going to be solving LeetCode 1836, remove duplicates from an unsorted linked list. So we're given the head of a linked list, and we need to find all the values which appear more than once within the list and delete the nodes that have any of those values. So in example 1, we're given 1, 2, 3, and 2. We want to return the list 1, 3. And as we can see, 2 occurs more than one time, so we just delete all the occurrences of 2 within our list. So how can we go about solving this? Well, what we can do is create an empty dictionary, which is going to store the counts of every node that we run into within our list, right? So we'll loop through our list initially and grab all the counts of all the values. And then we will build a brand new list using the nodes that only occur once. That'll give us the end result of our list. And in example 1's case, it'd be a list of 1 pointing to 3. So let's do this. We'll say counts is going to be equal to an empty dictionary. Our current node or current pointer will be equal to our head. And we want to loop while current is not none. What do we want to do when we run into a value? We want to say if that current.val is not in our counts dictionary, we want to initialize it. So we'll say counts of current.val will be initialized to 1, and then else if current.val is in our counts variable, right, meaning we ran into it already before, then we just want to increment the count by 1. So counts of current.val plus equals 1. And then we will increment our current pointer to be current.next. So let's print out our counts dictionary. Give us some space here, see what we're working with. Invalids, this should be not in, not is not in. Okay, we can see 1 occurs one time. In example 1, it does. 2 occurs twice. Okay, so far so good. 3 occurs once. Perfect. Now, we need to, in order to loop through and build a new list, right, we need to know how many nodes we're eventually going to build, right? So let's loop through. Let's create a variable called length. This is going to contain the length of the list that we're going to build. So we'll say for the value in our counts dictionary, if that value is equal to 1, we are going to increment our length by 1. All right, we only care about the values that occur one time. Everything else we don't care about. So let's print out our length. Would help if I spell things correctly. Okay, so we get a length of 2, and as we can see in example 1, right, they give us a return list of length 2. So that is going to be our condition for looping. We're going to say while length is greater than 0, we want to do something. What do we want to do? We want to add nodes to a list. Well, we don't have that list yet, so let's create that. We'll say dummy is going to be equal to a list node. We will give it the initial value of none, and we will set a current pointer equal to that dummy node. Okay, now that we have that, how do we add nodes, right? Well, the length is greater than 0 as of right now. So on our first iteration, we are going to grab the first node in our counts, first value in our counts dictionary. So we'll say current.next is going to be equal to a list node. What is going to be in this list node? It is going to be, and here, this is something I forgot to do. We should loop through, we should have an array of the values that occur once. So let's say values is going to be equal to an empty array, and when we loop through this dictionary to grab the counts and the length, we'll just also add that value to our values array. Values.append the val, should be the val. So let's comment this out real quick. Let me print out this values array just to see what we're working with. Okay, so 1 and 3, perfect. So what we could do is we could get rid of this length variable, and then we could just loop while we have values to loop through. So we'll say while the length of our values is greater than 0 or is not equal to 0, what do we want to do? We want to set current.next equal to a list node of some value, right? This value is going to be the first node within our values array. So we'll say value is going to be equal to values.pop0, and this is a worse runtime than just popping from the end. So what we could do is we could also make this a dequeue with an empty array, and then we could pop from the left side to get an O of 1 access time. Now it is a worse space complexity, but it does give us a better time complexity, and generally we want to prioritize time complexity above space complexity, so that's what I'm going to do here. Okay, so now we need to add let's get back to adding the value to our list. So our list node is going to be equal to the value we just popped off, and then we can set current equal to current.next, and this should be current, not cur. Okay, now what do we have to do now? What do we have to do? I think we are pretty good, so let's print out dummy.next to make sure we've added everything. And there we go. We have a list node of 1 to 3, just like how example 1 wanted. So let's check out example 2, right? Example 2 wanted none, right? The empty list. Example 3 also wanted a list from 1 to 4. Is that what they wanted? That is indeed what they wanted. So let's return dummy.next and see what happens. See if we get the right answer. I think we're on the right track. Perfect. We pass all 3 test cases, so let's submit. Awesome, and we do pass. Perfect. So time and space complexity. Time complexity is going to be O of n for this problem. We're doing an O of n pass, another O of n pass here, and a final O of n pass here as well. So O of n plus O of n plus O of n simplifies down to O of n. Space complexity, like I said, is going to be a little worse than the time complexity for this problem. It's going to depend on the length of our counts variable, or our counts dictionary, counts.length, and it is going to depend also on the length of our values array, and I believe that is it. Also the length of the list that we're rebuilding. So we could also say new list.length. All right, that'll do it for LeetCode 1836.